Hello, my name is Arthur, and in the last video we did some setting up to get ready for this video, basically. And, oh well, there was an oversight here on the tank. When I set up the collision shapes for the tank, I only actually addressed it as a two-dimensional thing, and I never did look at it from a front view. And from a front view, the collision shapes are not quite right. So let's pull this one in, and we'll just line it up with the wheels. And then for the collision polygon, all we have to do is change its depth. So its depth would be somewhere around half of what it is, plus a little bit. So let's try that at 7.57, and that's about right. That'll work. That should work just fine. On the selected material, I've altered this material a bit so that it shows up a little bit more. So I increased its emission a little bit, and I increased its opacity a little bit. So I increased the number for alpha up to 25, I think it was. I've also made some changes to the shell. I've disabled the area, and I've re-enabled the collision shape for the rigid body so it can bounce off of the floor again, and that's done with some reason. In the test map, I've not made any changes, but I have done some scripting. So we're going to go back to the tank script for a reminder. So to go along with the selected node, we created a function to turn the visibility on and off. Now we'll set up a second function. We don't have an ability to move this unit yet, but we'll put a function in called set destination. We'll just use the same variable. We'll send it a value, and we could call that position if we wanted to be more specific. So we could go like underscore position. That way we remember it's receiving a position, but that should be kind of obvious. And here we would set a variable to that position, but because we don't have a variable or any ability to move, we'll just print as a confirmation that we've created the ability to set a destination to this kinematic body. So we'll print trying to move to, comma, underscore position. So we'll have a look at what's been done in the terms for the floor script. So I've just attached a script that extends spatial because it's attached to a spatial. I called it world because it would be the script for any map. So this script would be attached to any map. The variable here, shell, that's just for a confirmation. So I'm using the shell as a confirmation piece. Function unhandled input. Now this is all written, and the reason it's written is because all I can really do is make a video showing how I went online to find how to do this. Basically, we're using unhandled input because if we have a menu that we click on with the mouse, that's handled input. Unhandled input is when we click on the viewport for no apparent reason. So when we left click onto the viewport, it's going to measure the event pressed, It's going to create a number of variables, ray length. It's going to get the camera. Um, then it's going to use a couple of functions of the camera, project ray origin, and we feed in the event position. That's the position of the mouse click to create from and to positions, and the to position is created with the from position, so we need to get the from position. Again, we're using project ray normal and project ray origin. These are camera functions meant for doing exactly what we're doing, picking something off of the 3D space through a two-dimensional viewport. So again, that gets event position, and it's more or less it's drawing a line from the camera to the mouse and through the mouse by the ray length of 1000. This comes from the documentation, so I'm pretty sure that 1000 is just a number that well, it's not likely you can even see past 1000 through the camera. I think you can see 100 on the camera by default. So it's just a length of a line to draw to get the position at the end of that 1000. Then what we're doing is we're using get world direct space state to create an intersect array. And the intersect ray starts at the camera and ends at the end of the line that we created from the camera functions. And if there's anything intersecting that ray, it's going to get a result. So right now, there's actually the situation is that it's going to instance a shell at the point of the mouse click, and then I've added a little bit onto Y so that the shell is instanced slightly above the ground. Otherwise, in certain places, it's going to fall into the ground. So I've added a little bit just so that the shell stays above the ground. So with the way this is written right now, it can throw an error because this test is only going to work if I click somewhere that returns a result. And if I click up in the sky, it's not going to return a result. The result will be null, and this would throw an error because translation wouldn't exist. This is all null. So we'll just have a look and see that this is all working because this is a test. So what we expect to see is a shell created wherever I click. And if I click in the sky, it's going to give a invalid index because there's no X, Y, and Z to a null. So basically, we don't need this anymore. We're going to get rid of that. So let's just comment it out for now, just in case, because sometimes that's what I do with something like this, is I just comment it out. So with that commented out, we would be like, we're going to need a variable. So we're going to create a variable unit, and we're going to check for a result, because if there's no result, we don't want it to try to do stuff with a non-existent result. So if result, and then we would be, let's see, if result dot collider dot is in group player, That was a mistake there. If result dot collider is in group player, unit equals result dot collider. So what collider is that's a reference. It is the kinematic body in the case of the player. So now we would be able to go unit dot select underscore selected true. So that will toggle on selected equals true. Now, if result dot collider is in group map, and that's supposed to be a period, and this is supposed to be a period. So if result collider is in group map and unit, so that means unit is not null. Unit dot set destination result dot position, and that's the position of intersection. Because the result is a library, it knows what collider is, it knows what position is. We'll look at that the next time around here. Then we would be unit dot set selected, unit underscore selected false, and unit equals null. Now for that to work on the actual map, we can see I've put ground into a group, it's in the group map, and I've put the hill into the group map. So when we click on that, the collider is in the groups saying that these are places you can move to. So that gives us our check. And let's see, is that everything? So for now, that's everything. That should work. So we'll clear that error off. We'll give it a go. Okay, so it's not doing anything but printing, and this is the result. So when we go result.collider, that's part of being a library. It's going collider. The next thing after collider is the static body. We can look for the collider ID, the normal, and the position. So result.position, this is the position that the mouse clicked on. And then for the shapes, well, I'm not sure what's with these different shape numbers. That's a little bit of a mystery to me. Oh, that's interesting. That actually has to do with the lines in the tri-collision mesh. So we have 12, this would be 13, 14. So that's another thing to know. I guess it doesn't really matter very much. So we'll test it out. We can select the unit. It gets a little selection bubble around it for our unit selected effect. And then it's trying to move to the position we click to. And because we've already spawned shells in these click positions, we know that it's going to try to move to that position. So yeah, that's coming along. I'm not really sure about attempting to do a box select and make it so that multiple units can be moved at the same time. That starts getting pretty complicated. Um, Maybe in the long run, that would be something that I would try to do with this. But for now, I'm going to be looking into how to get the tank moving to the destinations and how to do that in a 3D space, because I've only ever done this in 2 dimensions. So this is all kind of experimental and new to me, and I'm probably not going to be doing a heck of a lot of typing out script to get that working. But yeah, I can do videos on how I get it working, and the things that I can script on video I'll do for the sake of maybe it will be helpful to people. So I hope this video was helpful and that this is some good content. And yeah, that's about it for this video. In the next video, we'll be looking at getting the tank driving to destinations, and then it'll be time to get the turrets targeting things. So until then, take care.